Section 6.3.7. The random variable x follows a Poisson process with the given mean. Assuming the mean is equal to 8, we're going to compute the following. Part A, where the probability is exactly 4. Part B, where the probability of x is less than 4. Part C, the probability where x is greater than or equal to 4. And Part D, the probability where x is in between 5 and 9. So, let's go ahead and start. So we're going to use the formula for the Poisson process with the given mean, and we know the mean is 8. So, using the formula, we know that it's going to be the probability of x, and so in our problem, we have x, and that's equal to 4, because that's exactly 4. And then the mean is given as 8, so that means that 8 is going to represent the mean. So let's go ahead and plug it in our formula. So we have 8 for the mean, and we know that the value of x is 4. So let's go ahead and plug it into our calculator. So using parentheses, left parenthesis, we have 8 to the power of 4. Okay, and then we're going to divide that by 4 factorial. So 4, go to math, scroll to the right for probability, and then down the number 4 for the factorial symbol, plus right parenthesis, and then we're going to multiply that by e, so that's second, and then the ln button, because there's e to the x, to the negative 8. And then we're going to close the parentheses, and then press enter. So we get 0.0572523, which is what we get here, and then we want to round it to 4 decimal places, so we get 0.0573. So that is the first one. Okay, now the second one, we want to find the probability that x is less than 4. So, in this case here, when the probability of x is less than 4, well, that's equal to the probability of where x is less than or equal to 3. So what that means is, we're finding the probability of 0 plus the probability of 1 plus the probability of 2 plus the probability of 3. So let's take a look at each individual formula. So we know that the value of x is 0, so we can see that 0 is given for the value of x, and we know that our mean is going to be 8 in that formula. Okay, the next one, we know our value of x is 1, so we have 1 represents x, and again our mean is represented by 8. Okay, the next value is the probability of 2, so we know that x represents 2, and again the mean is 8. And then the last one, we know the value of x is 3. And again, we know the mean is 8. So we're going to plug it into this formula and then add them together. So let's go ahead and do that. So we can come up here, and if we wanted to, we can press enter. And then we're going to go ahead and put in the value of 0 in place of 4. So there's 0. And then we're going to replace the 4 here with 0. And then what we're going to do is just press enter. And that's going to give us 3.3546263. This is times 10 to the negative 4, so we have to move the decimal place over to the left 4 times, okay, which gives us 0.0. If we move it over 4 times, 1, 2, 3, 4, we get 0.000335.462, which is what we get here. Okay, now let's go ahead and now change the value of x to 1. So we're going to come back up here. Okay, and then we're going to change our values, that the zeros is now going to become 1. Okay, and then let's go ahead and press enter. And then that gives us the following. It gives us 0.0026837. And we can go further if we wanted to as far as decimals are concerned. This is enough. Okay, next, we're now going to go ahead and then we're going to go highlight over that and press enter again. And now we're going to change the values of x to be 2 now. So this is 8 to the second power over 2 factorial. And then let's press enter. And then we get 0.017348. And then the last one, we're now going to change the values of x to be 3. So let's press enter. So this is going to be 8 to the third power divided by 3 factorial. And so therefore, pressing enter, we get 0.028621. And again, it's going an extra 2 decimals that I have here. So if we add those all up, we get 0.042380111. Rounding this to 4 decimal places gives us 0.0424. So the probability that x is less than 4 gives us this result. Okay, now this is the probability in part C that x is greater than or equal to 4. Now remember, when it's greater than or equal to 4, then we always use the at least formula. The at least is the probability of x being greater than or equal to 4 is the same as 1 minus the probability of x being less than 4. Well, we did the probability of x is less than 4 because we know it's x is less than or equal to 3 in the previous problem. So therefore, it becomes 1 minus the probability of x being less than or equal to 3. So what did we get for that? Well, the probability that x is less than or equal to 3 was 0.0424. So we're going to take 1, and then we're going to subtract 0.0424, and therefore we're going to get the probability of 0.9576. Now the last one, we want to find the probability that x is in between 5 and 9 inclusive. So the probability that x is in between 5 and 9 inclusive is equal to the probability of 5 plus the probability of 6 plus the probability of 7 plus the probability of 8 plus the probability of 9. So what that means is, in our formula, the value of x is going to be 5, 6, 7, 8, and 9. And remember that the mean stays 8. So what do we know? We know that, again, the mean is going to be the value of 8. So we know that that stays the same. Okay, now the values of x. We know it's the probability of 5, so therefore x has become 5. These x's become 6. The probability of 7, there's 7. Probability of 8, and then the probability of 9. So now each individual formula, we're going to go ahead and then find each particular probability. So let's go ahead and do that. So on our calculator, we can come in here, we can go ahead and we can press enter for that result and then change the values of x to be 5. So there's 5, 8 to the 5th power divided by 5 factorial times e to the negative 8, and that gives us 0.0916037. Okay, then we're going to go ahead and press enter again, and now this is going to become 8 to the 6th power divided by 6 factorial times e to the negative 8, and that gives us a probability of 0.1221382. Again, we're going to take the value here, we're going to press enter, and now this becomes 8 to the 7th power divided by 7 factorial times e to the negative 8, and then we get a probability of 0.1395865. Okay, let's move this over and let's do this again. So by highlighting and pressing enter, now we're going to have 8 to the 8th power divided by 8 factorial times e to the negative 8, and that gives us 0.1395865. And then the last one, we're going to go ahead now and change this to 8 to the power of 9 divided by 9 factorial times e to the negative 8, and that gives us 0.1240769. And so therefore, now what we're going to do is we're going to add those all up to get 0.6169918, and then rounding that to 4 decimal places gives us the probability of 0.6170. So let's go ahead and just verify our results on my stat lab. So we can see that the first one is 0.573, and that's what we got for the first one. The next one was 0.0424. 0.0424. Part C is 0.9576. Let's go ahead and put that in there. 0.9576, and the last one we had was 0.6170.